Hello, welcome back. In this practical, we're covering worksheet 7, which is all about how to interpret a significant interaction using simple effects analyses. A simple effects analysis is really similar to a post hoc in that you perform the test after a significant result, whereas a post hoc looks at the significant impact of one independent variable on the DV. A simple effect looks at this combined influence of two or more independent variables on the dependent variable of interest. So for our practical this week, we'll be using the same exact data set we did last week. We're just continuing on with the analyses. Remember that last week we stopped at the factorial ANOVA or the omnibus ANOVA. Here we're going to continue on to interpret that significant interaction. Before we begin, let's go ahead and quickly revise the results from the factorial ANOVA last week. The overall research question that we're assessing here simply asks if alcohol consumption and gender impact attractiveness ratings in heterosexual individuals. Therefore, attractiveness ratings is our dependent variable. This is numeric, and higher values mean that the rater found the image more attractive. And we have two independent variables. That's what makes this a factorial ANOVA. We have two independent variables of interest. The first one being sex, which is two levels, female and male. The second one being alcohol consumption, and this is a three-level categorical variable. Participants either had 0 pints, 2 pints, or 4 pints of beer. So now that we've refreshed the purpose of this study, let's go ahead and refit that factorial ANOVA just to remind ourselves the results of the two main effects and interaction that we assessed. All right, the first thing we have to do is import the data set. Again, we're using this exact same data set as we did last week, beergoggles.dta. Let's first get some summary statistics to remind ourselves the data that we're working with. The command we're going to use today is tabulate, and we want the tabulation for sex and pints. Then, comma, summarize our dependent variable attract. This command will give us the cell and marginal means table, similar to the one we produced last week. However, we're using a slightly different command this week. So again, this is another example of how you can get the same information in many different ways in Stata. So we can see here we have the mean, standard deviation, and number of observations for each of the 6 cells, as well as the marginal means. Remember that the marginal means are the influence of one independent variable averaged across the other independent variable. So for example, we have pints represented in columns with the marginal means for pints at the bottom. So this is the average attractiveness rating for everyone who had 0, 2, and 4 pints of beer, regardless of gender. And similarly, we have the marginal means for gender, so the attractiveness ratings provided by males and females, regardless of alcohol consumption. Again, these are considered the marginal means. We also have the 6 cell means. And the cell means are what we're going to be using to really dig into the interaction that we saw. Remember that there was a significant interaction, and we want to know the differences between these means. So, for example, is the mean attractiveness ratings for males at 0, 2, and 4 different, as well as females at 0, 2, and 4? Another way to consider this is asking, are males and females different after 0 pints of beer? Do males and females differ after 2 pints of beer? Or do males and females differ after 4 pints of beer? So we're going to demonstrate two different ways to really understand the interaction using simple effects analyses. So you were given quite a few commands in your worksheet this week. In the future, in your own work, you don't have to do both methods of simple effects to understand an interaction. It really depends on what makes most theoretical sense. And in fact, you'll see through this demonstration which method of doing the simple effects is the most useful. Okay, so let's go through the practical and then we'll decide at the end which is the best way to understand the interaction. And before we do that, let's fit the ANOVA model first and consider the main effects and interaction as well. Right? I'm not going to spend any time interpreting the statistics from the source table or the ANOVA table. I just want to revise what was significant and what was non-significant. Right? So just like before, the main effect of sex is non-significant. So again, regardless of number of pints consumed, men and women did not differ in how they rated attractiveness. The main effect of pints, on the other hand, is statistically significant. This means that regardless of sex, regardless of being male or female, people who drank 0, 2, and 4 pints did significantly differ somewhere. Now, if we have a non significant interaction, in order to understand this main effect, you would have to do post hoc analyses. However, in this case, we do have a significant interaction, which means we can essentially skip the post hoc analyses and use simple effects to really understand where those differences are. So let's go ahead and visualize this before we move on to the simple effects analyses, the contrasts. Remember last week we discussed how an interaction is essentially the difference of differences. And this makes the most sense, at least for me, when I can actually visualize this in a plot. So we're going to demonstrate this in two different ways. In fact, we're going to visualize this in four different ways, both using line plots and bar graphs. But we also need to decide the most impactful way to visualize these data.